This video is about problem solving and modeling with series. Let's go through a few questions about modeling with series now. The adult population of a town is 25,000 at the beginning of 2012. So A is equal to 25,000. A model predicts that the adult population of the town will increase by 2%. So that means my R will be equal to 1.02 if it's increasing by 2% each year, forming a geometric sequence. Show that the predicted population at the beginning of 2014 is equal to 26,010. So that means when at the beginning, when n is equal to 0, we have beginning of 2012, we have 25,000. When n equals 1, we have the beginning of 2013, which will be 25,000 times 1.02. So when n equals 2, we have beginning of 2014, which will be equal to 25,000 times 1.02 squared. So that means if I want to find out predicted population at the beginning of 2014 is equal to 25,000 times 1.02 squared, which if you put that into your calculator, you get 26,010. Okay. The model predicts that after n years, the population will first exceed 50,000. So that means if n is equal to n, then it will be 25,000 times 1.02 to the power of n. Okay, so that means we want 25,000 times 1.02 to the power of n to exceed, so will be greater than 50,000. Okay, so first thing we need to do is divide by 25,000. So 50,000 divided by 25,000 gives you, if I write it out, 50,000 divided by 25,000, which is equal to 2. Next, we need to take logs on both sides. So log 1.02 to the power of n is greater than log 2. Applying the laws of logs, the n comes down. So n log 1.02 is greater than log 2. Because 1.02 is greater than 1, it means we can divide, and obviously it's a positive number we're dividing by, so the equality stays the same. So n is greater than log 2 over log 1.02. And that's part B done. Okay, part C. Find the year in which the population first exceeds 50,000. So if we put that into our calculator for part C, n is greater than, if we put log 2 over log 1.02 into our calculator, we get 35.00278, blah, blah, blah. So n will be equal to 36. Therefore, 2012 plus 36 is equal to 2048. So the first year in which the population exceeds 50,000 is 2048. Okay, part D. Every member of the adult population is modelled to visit the doctor once per year. Calculate the number of appointments the doctor has from the beginning of 2012 to the end of 2019. So in this case, our A is 25,000. My R is 1.02. From the beginning of 2012 to the end of 2019 is the same thing as doing 2019. Take away 2011, which is 8 years. Therefore, n is equal to 8. So what we're in essence calculating is S of 8. So using S of n is equal to a times 1 minus r to the power of n over 1 minus r. We get S of 8, S of 8 is equal to A, which is 25,000 times 1 minus 1.02 to the power of 8, all over 1 minus 1.02, which is equal to 214,574.2263. So rounded to the nearest number, that means it's equal to 214,574. So that's the number of appointments the doctor has from the beginning of 2012 to the end of 2019. E. Give a reason why this model for doctor's appointment may not be appropriate. So that's because the number of visits depends on the health of the patient. Therefore, some people may visit more frequently, e.g. elderly, vulnerable people. And some will not visit at all. So healthy people might not visit at all. Okay, next question. Kyle is making some patterns out of squares. He has made 3 rows so far. Find an expression in terms of n for the number of squares required to make a similar arrangement in the nth row. So row 1 has 3 squares. Row 2 has 5 squares. And row 3 has 1, 2, 3, 4, 5, 6, 7. So 7. So you can see this is a linear sequence. So un, because it's increasing by 2, so it's 2n and then plus 1. So un is equal to 2n plus 1. B. Kyle counts the number of squares used to make the pattern in the kth row. He counts 300. So somewhere in row k, there's 301 squares. Okay. Write down the value of k. So that means using un is equal to 2n plus 1, we get uk is equal to 2k plus 1, which implies 301 is equal to 2k plus 1, which means 300 is equal to 2k, which means k is equal to 150. So it must be 150 row. Okay, part B and now part C. In the first q rows, Kyle uses a total of p squares. Okay, show that q squared plus 2q minus p is equal to 0. Okay, that means we're using Sn, because it's a total, is equal to n over 2, is an arithmetic sequence. So we have to use the formula for the arithmetic series, where a is equal to 3. The common difference is increasing by 2, so it's 2. The number of rows is q, so n is equal to q. And we know the total needed Sn is equal to p. So using total of p squared in the first q rows. So this is your n and this is your Sn. Okay, so therefore we have S of n, which is p, is equal to q over 2. 2 times 3 plus n minus 1 is q minus 1 times d, which is 2. Okay, if we simplify, we get p is equal to q over 2, 6 plus 2q minus 2, which means p is equal to q over 2, 4 plus 2q. If we divide everything inside the bracket by 2, we get q times 2 plus q, which means we get p is equal to 2q plus q squared, which means q squared plus 2q take away p is equal to 0, which is what we wanted. Okay, part 2. So that was part 1, sorry. Given that p is greater than 1520, find the minimum number of rows that Kyle makes. So 2. We've got P is greater than 1520, which means we've got Q squared plus 2Q minus P is equal to 0 from part 1, which means Q squared plus 2Q is equal to P, which is greater than 1520, which means Q squared plus 2Q must be greater than 1520, which means Q squared plus 2Q minus 1520 is greater than 0. If I factorize this, I've got Q plus 40 and Q minus 38. So if I think about quadratic inequalities, I've got 38 here and I've got negative 40 here. It's a positive Q squared, so it's like this. We're looking for the part that's greater than 0, so we're looking for that part. Q can't be negative because we can't have negative rows, so that means Q must be greater than 38, so it can't be this far because it can't be negative. Q can't be negative, number of rows cannot be negative. So Q has to be greater than 38, which means Q must be equal to 39. So minimum number of rows is equal to 39. Prospectors are drilling for oil. The cost of drilling to a depth of 50 meters is £500. So £500 is 50 meters. To drill a further 50 meters costs 640. So if you plus 50 more, you're getting to £640. And hence the total cost of drilling to a depth of 100 millimeters is 1,140. For each subsequent 50 meters, you're adding another 140, which gives you 780 for the next one. Add another 50 meters, you're getting 920. So what you realize is you're adding £140 each time. Which means A, show that the total cost of drilling to a depth of 500 meters is 11,500. So that means you've got the sequence 500, 640, 780, blah, blah, blah. Where A is equal to 500 and the common difference is 140. Now 500 meters is equal to 10 lots of 50 meters. Therefore, N is equal to 10 in this case. So if I using Sn is equal to N over 2 times 2A plus N minus 1 times D, I get S of 10 is equal to 10 over 2 times 500 plus N minus 1 is 10 minus 1 times D, which is 140. And if you put that into your calculator, you end up getting 11,300. B. The total sum of money available for drilling is £76,000. Find to the nearest 50 meters the greatest depth that can be drilled. So we have S of N has to be equal to 76,000. So that means using Sn is equal to N over 2 times 2A plus N minus 1 times D, we get 76,000 is equal to N over 2 times 500 plus N minus 1 times 140. If I simplify this, I get 1,000 take away 140, which gives me 860 plus 140N, which means 76,000. If I divide the bracket by 2, I end up getting 430 plus 70n. To go over here, which means I've got 76,000. 76,000 is equal to 430n plus 70n squared, which means 70n squared plus 430n minus 76,000 is equal to 0. So n will be equal to minus b, which is minus 400, using the quadratic formula, minus 430. Is it 430? I feel like I made a mistake. Okay, oh, I realized I can divide by 10. I could have divided by 10 here before I use the quadratic formula. So I get 7n squared minus 43n take away 7,600 is equal to 0. Okay, using quadratic formula, n is equal to minus 43 plus or minus 43 squared minus 4 times 7 times minus 7,600 all over 2 times 7. If I put that into my calculator, I get n is equal to 30.02 or n is equal to minus 36.16. Now, because n is the number of terms, n has to be greater than 0. So as n is greater than 0, n must be equal to 30.02. Therefore, n equals 30. Okay, next question. The man who invented the game of chess was asked to name his reward. He asked for 1 grain of corn to be placed in the first square of his chessboard, 2 on the second, 4 on the third, so on until all the 64 squares were covered. He then said he would like as many grains of corn as the chessboard carried. How many grains of corn did he claim as his prize? So that means on the first square he's got 1, in the second square he's got 2, third square he's got 4, then it would be 8, so on. So what we realize is this is 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3, all the way up to 2 to the power of 64. So it would be 2 to the power of 64. It would be 2 to the power of 63 actually, because we've already got to the power of 0. So because if 64 squares, it would be 2 to the power of 63. So in this case, your a is equal to 1, the first term. Your r, your common ratio, is your timesing by 2 each time. So your common ratio is 2. Your n, although is 2 to the power of 64 is the last term, there's actually 64 terms here. So n is equal to 64. So using Sn is equal to a times 1 minus r to the power of n over 1 minus r. You get S of 64 is equal to A, which is 1 times 1 minus 2 to the power of 64, all over 1 minus 2, which gives us the value of, if you put this into your calculator, it gives us a very big number, 1.84467, blah, 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 times 10 to the power of 19. We round it to 3 significant figures, I get 1.84 times 10 to the power of 19. Okay, the geometric series has first term a and common ratio r. Prove that the sum of the first n terms of the series is a times 1 minus r to the power of n over 1 minus r. So that means Sn, so remember in a geometric series we've got a times r squared, all the way up to a times r n minus 1. So Sn will be equal to a plus ar plus ar squared plus ar cubed plus all the way up to ar n minus 2 plus ar n minus 1. Now R times Sn will be equal to AR plus AR squared, because we're multiplying everything by R. So we're not going to get A, but we're going to get AR plus AR squared plus AR to the power of 4 plus AR to the power of n minus 1 plus AR to the power of n. Now if we call this 1 and if we call this 2, if we do 1 take away 2, on the left hand side we get Sn take away R times Sn is equal to, if you subtract everything on the top, on the right hand side with everything on the bottom on the right hand side, we just end up with A. We just end up with A take away AR to the power of n. If we factorize it, we get Sn is equal to Sn times 1 minus R and A times 1 minus R to the power of n. So Sn must be equal to A times 1 minus R to the power of n over 1 minus R, which is what we needed to prove. Okay, next part. Mr. King will be paid a salary of $35,000 in the year 2005. Mr. King's contract promises a 4% increase in salary every year. The first increase being given in 2006, so that his annual salaries form a geometric series. So for B, we've got A is equal to 35,000 and R is equal to 1.04 as it's increasing by 4%. So find to the nearest £100 Mr. King's salary in the year 2008. So if we're looking at 2000, first year is 2005 will be equal to is 35,000. So 2006 will be 35,000 times 1.04. 2007 will be 35,000 times 1.04 squared. So 2008 will be 35,000 times 1.04 to the power. So 2008, will be 35,000 times 1.04 to the power of 3. Which, if we put into a calculator, we get 39370.24. To the nearest thousand, this is £39,400. Okay, C. Find Mr. King receive a salary each year from 2005 until he retires at the end of 2004. Okay, find the nearest £1,000, the total amount of salary he will receive in the period from 2005 until he retires at the end of 2024. So first thing is we're doing end of 2004, take away beginning of 2005. So to work out n, it's going to be 2024, take away 2004. So the previous year from when he started working. So n equals 20. 20. So using Sn is equal to A times 1 minus R to the power of n over 1 minus R. We end up getting S of 20 is equal to A, which is 35,000 times 1 minus 1.04 to the power of 20, all over 1 minus 1.04. In our calculator, we get £1,042,232.75. This nearest thousand is going to be 1,042,000. Nearest thousand, 42,000. Next question. A trading company made a profit of 50,000 in 2006, year 1. So 2006 is year 1 is 50,000. Year 2, which will be 2007, is 50,000 times R. 2008, which is year 3, will be 50,000 times R squared. So if it's year n, will be 50,000 times R to the power of n minus 1. A model for the future trading predicts the profit will increase year by year in a geometric sequence with common ratio R. The model therefore predicts that in 2007 year 2, a profit of 50,000 times R will be made, which is what I've done on the left hand side. Write down an expression for the predicted profit in year N. So that'll be, I've just worked it out, it'll be profit will be equal to 50,000 times R to the power of N minus 1. B, the model predicts that in year N the profit will exceed 200,000. So that means 50,000 times R to the power of N minus 1 will be greater than 200,000. If we divide both sides by 50,000, we end up with 4 on the right hand side. Because we've got n, which is unknown, we want to in the subject of the formula, we'd need to take logs. So log R to the power of N minus 1 is greater than log 4, which means using the log laws, N minus 1 times log R is greater than log 4, which means N minus 1 is greater than log 4 over log R. Now we can divide by R and not change the inequality because R is greater than 1. Okay, which means N must be greater than log 4 over log R plus 1, which is what we wanted. Okay, see? Using the model with R is equal to 1.09, find the year in which the profit made will first exceed 200,000. So now we just need to substitute in our answer for part B, 1.09. So N is greater than log 4 over log 1.09 plus 1, which means N is greater than 17.08646, which means N is equal to 18. D, find the total of the profits that will be made by the company over the 10 years from 2006 to 2015, inclusive, giving your answers to the nearest 10,000. So we have A is equal to 50,000, R is equal to 1.09, N is equal to 10, Sn is equal to A times 1 minus R to the power of N over 1 minus R, which means S of 10 is equal to 50,000 times 1 minus 1.09 to the power of 10 all over 1 minus 1.09, which gives us an answer of 759,646.4859. If I want it to the nearest 10,000, it's the same thing as 760,000. A car was purchased for 18,000 on 1st January. On 1st January each following year, the value of the car is 80% of its value on 1st January in the previous year. Show that the value of the car exactly 3 years after it was purchased is 9216. So for A, your first term is 18,000. Your common ratio is 0.8. So a value after 3 years will be equal to 18,000 times 0.8 to the power of 3, which gives me in my calculator 9,216. B, the value of the car falls below 1,000 for the first time n years after it was purchased. So that means 18,000 times 0.8 to the power of n will be less than 1,000. And to solve this inequality. So that means if I divide by 18,000, 0.8 to the power of n is less than 1,000 divided by 18,000, which is 1 over 18. Log of 0.8 to the power of n is less than log of 1 over 18. N log of 0.8 is less than log of 1 over 18. Because we're dividing by log of 0.8, which is between a number between 0 and 1, is negative, so n must be, the inequality will change sign, so n must be greater than a log of 1 over 18 divided by log of 0.8, which means n is greater than, from my calculator we get n is greater than 12.9529, which means n is equal to 13. See? An insurance company has a scheme to cover the cost of maintenance of the car. The cost is £200 for the first year. So £200 for the first year. And for every following year, the cost increases by 12%. So it'll be 200 times 1.12, 200 times 1.12 squared, blah, blah, blah. So that for the third year, the cost is £250.88. Okay, so that'll be 1, 2, 3. That must be this one, 250. This one, £250.88. Find the cost of the scheme for the fifth year, giving your answer to the nearest penny. So this is A is equal to 200, R is equal to 1.12. If I'm trying to work out fifth year, N is equal to 5. So using UN is equal to AR to the power of N minus 1, I've got U5 is equal to 200 times 1.12 to the power of 4, which is equal to 214.703872. And if I want it to the nearest penny, that will be £314.70. Find the total cost of the insurance scheme for the first 15 years. So D. So you got, because it's a geometric series, S of n is equal to A times 1 minus R to the power of n over 1 minus R. We're trying to work out 15 years, so S of 15 is equal to A, which is equal to 200 times 1 minus 1.12 to the power of 15, all over 1 minus 1.12. If we put that into our calculator, we get 7455.94293, blah, blah, blah. We're rounding it to the nearest penny. Let's do that, which gives us £7,455.94. The last question I'll go through. So the adult population of a town is 25,000 at the end of year 1. So 25,000. The model predicts that the adult population of the town will increase by 3%, so it'll be 25,000 times 1.03, 25,000 times 1.03 squared, and so on. Forming a geometric series. Show that the predicted adult population at the end of year 2 is 25,750. So in this case, A is equal to 25,000, R is equal to 1.03. So at the end of and we have N is equal to 2. So using UN is equal to AR to the power of N minus 1. U2 is equal to 25,000 times 1.03 to the power of 1, which is equal to what we wanted, 25,750. B. Write down the common ratio of the geometric sequence. Increase by 3% means 100% plus 3%, which is equal to 103%, which is equal to 1.03. Therefore, R is equal to 1.03. C. The model predicts that year N will be the first year in which the adult population of the town exceeds 40,000. Show that, so on. So that means A is equal to 25,000. R is equal to 1.03. N is equal to N. Using UN is equal to AR to the power of N minus 1, we get, we have also using that, and UN is greater than, also the fact UN is greater than 40,000. Then we got A, which is 25,000 times 1.03 to the power of N minus 1 is greater than 40,000. When I do 40,000 divided by 25,000, 1.03 to the power of n minus 1 is only on the left-hand side. 40,000 divided by 20,000 is the same thing as 40 divided by 25, which is 8 divided by 5, which is 1.6. So log of 1.03 to the power of n minus 1 is greater than log of 1.6, which means n minus 1 log of 1.03 is greater than log of 1.6. Which means n minus 1, because this number is positive, the inequality stay the same. So I get log of 1.6 divided by, oh, I don't need to do any more. This is what I wanted, sorry. I was trying to solve for n, but this is what we're trying to show for part C. So that's done. D is find n, then now I continue on. So n minus 1. n minus 1 must be greater than log of 1.6 divided by log of 1.03. So n must be greater than log of 1.6 divided by 1.03 plus 1, which is n is greater than, when I first put the log stuff into my calculator, I get this plus 1. So n is greater than 16.90063, which means n is equal to 17. That's D. Okay, at the end of each year, each member of the adult population of the town will give £1 to a charity fund. Assuming the population model, find the total number that will be given to the charity fund for the 10 years from the end of year 1 to the end of year 10, giving your answer to the nearest 1,000. So this is obviously working out SN. So for E, we've got A is equal to 25,000, your R is equal to 1.03, your N is equal to 10, Sn is equal to A times 1 minus R to the power of N over 1 minus R, which implies S of 10 is equal to 25,000 times 1 minus 1.03 to the power of 10, all over 1 minus 1.03. When you put this into the calculator, you get £286,596.9828, blah, blah, blah. If you want it to the nearest 1,000, same thing as 287,000.